Hey guys, this is Whalehater. This packet tracer that I'm doing today is for IP NAT translation. So I've been doing this project recently, trying to work on how to build a network from scratch. And this kind of came up and I struggled with it. I couldn't quite remember how it works. So I did some homework and try to do my best to figure out for you how this works. So I built a simple network. We've got a 1 network, a 2 network, and a 3 network. This is just a simple topology. Now, we're going to start addressing some of this stuff. I'm going to go to the desktop, and we're just going to give it some really simple addresses. 2. Over here, this is going to be 3 network, 2. Alright, this is something you may not have played with before, but I just I hooked everything up to the 0 interfaces here, so the gigabit 0 and the serial 0. So on the serial 0, you can actually turn these interfaces on and give them IP addresses without having to go into the command line, which is kind of nice, right? Let's do the serial, turn that one on. Okay, this one as well. It's going to be 333.2. Okay. So now we've got the 1 network, 2, and 3 networks. So we're going to switch over to, oh, hold on here. Forgot to do one other thing. We have to turn on router, some type of router information distribution system here. Let's just use router RIP version 2, and then let's give it some network commands. So the R1 is connected to the 1 network and the 2 network. So let's just punch those in. Alright, that should be done for that one. And the 2 networks here. Okay, so we should be done. Let's switch over to the simulation mode like we have. And we're going to ping PC 3 or whatever it is over there on the 3 network. All right. Let's just open up this PDU. Now we can see that going out, it's coming from the 1 network going to the 3 network. Okay, look at this here now. It's still coming from the 1 going to the 3. Everything's working as it should. This guy doesn't know about that, so he's like, wait a second, I don't know anything about that. So it's going to try again. This time it says, oh yeah, I know what you're coming from. So it sends it off to PC1. PC1 says, oh, okay, it's coming in on that network. I'm going to send it back out to, okay, so I'm replying to it. It's going to go out to PC1, 0, and it knows all about this, sends it off, and you get a reply. That's how that works. Now I'm going to pull up the show IP routes. So here's our routing table for R2. It learned about the 1 network over here. We configured the 2 and the 3 networks on it. Similarly, come on, show IP routes, and it learned about the 3 network, and then it knows already about the 1s and the 2s because it's been connected to those. So now we're going to configure NAT for these guys. Now we first have oops, we first have to do an access list. Standard 1. And this isn't a video about access lists, but you know, we're just going to use it quick. To do NAT, it requires one. We're just going to do a permit any. So any traffic that comes in, you can let it come out. So exit an access list is done. Next, we do the RP NATs, and we have to create a pool of addresses. And I just like to call mine capitalized pool. And the starting, we're just going to give it the for network, and it's the starting IP address and the ending IP address. So we're just going to give them both the same, since we just want one address. And then we could give it any, oops, we need to give it the net mask command, and we can give it any subnet mask. We're just going to give it to, a /24, 255, 255, 255, 0. Enter. So now there's our pool. So we've got our access list and our pool. Now we have to tie those two things together. IP NAT inside source list. I'll go back. You can either make a static address, so like a one-to-one translation, like this traffic coming from this computer always gets translated to this address globally. And for NAT, you have inside local addresses, and outside, everything outside is a global address. Inside is your network, outside is the rest of the world. So on R1, we're going to say list, since we want a list of access, who's allowed access. We're going to give that list 1. The pool of addresses we want you to translate it to is found in this named pool. And then we're going to give the overload command, and that is a little step up from NAT. It's actually called something called PAT. And what PAT does is it doesn't keep track of packets with IP addresses by handing out multiple IP addresses. All the packets on this network is going to use the same IP address, but they're going to use different I'm blanking on the name, port numbers. Whoa, it's getting kind of late and I'm tired. Yeah, different port numbers. So enter. Now what we did is we said we want a NAT translation from the inside going out. So only the addresses coming from inside are going to be translated. The source for allowing it is from this list, number 1. That was that standard list we did. Permit anybody to do this. The pool of addresses that I want you to translate to are found in this up here, and we're going to overload it. So you can use as much traffic as you want, just use different port numbers. I don't know why I was blanking on it so badly before. So now we're ready to go, except we need to define for the router what interfaces are its inside and which ones are its outside. So the gigabit 00 is going to be the inside network that we want it translating from, and here is the outside network that we want it translating to. So interface G00, and that is the IP NAT inside. So that's an inside interface. The interface, the one that's outside, is IP NAT. That says S000 outside. Okay, so now we are totally ready to go. So before, I just wanted to show you this quick. R2 learned about this route to R1, or to the network 1, through the serial 00 interface. Okay. Now we just turned on NAT. Now what NAT does is it makes R1 say, you know what, you don't need to know about this, because I'm just going to be translating addresses different from what's coming out of that network. So let's do the show IP route again, and let's just fast forward in time a couple. Let's give it one more. Oh, another one. Eventually it's going to say, okay, there it is. It's possibly down. So there's a timer that gets incremented, saying it's waiting for the next, every 30 seconds or so, RIP will send out an update saying, hey, there's new information, or here's the same information. So at least you know it's still available. Now that timer ran out, and R2 didn't get another update. So he says it's probably down. It's probably not a reliable source anymore. Let's just give it a couple more of these fast forward times, and then we will go up, show IP route, and you see it disappeared altogether. It's not there anymore because R1 is no longer sharing updates about network 1. It doesn't have to. It's like, you guys are the internet, you guys are the outside world, you don't need to know about my private addresses in here. You shouldn't even care about it. So let's ping. Let's switch over to the simulation again, and we're going to do a ping to the other PC one more time. Now let's open this up. It's coming. Our source is network 1. It's going to this network over here, network 3. Capture forward. Okay, let's open it up again. It's coming in from the 1 network. It's going to the 3 network, but going out, it's been translated. Now it's coming from the 4 network, and the IP address for the destination remains the same. Let's capture forward, capture forward. He says, yay, I love getting mail. I'm going to reply to network 4. The source is a network 3 now. It's going to network 4. Forward. Oh no! What's going on? So R2 said, I have no idea where network 4 is. Because if you remember, his routing table doesn't have a network 4 at all. And it doesn't have any place to send it, so it just drops the packet. So what we're going to do is we're going to give him some place to put that packet by giving him a default route. Do you remember how to do those? Of course you do. And we're just going to have it go out that serial interface. So now he's got a new route in his routing table that we just put there. He has a default route, so if I have no idea where a packet goes, send it out S000. It'll find its way there, hopefully, because my administrator told me. So let's capture forward. He got the mail saying undeliverable. So here comes the next packet, next ping. R1 knows what to do. It sends it out to R3. It's been translated now. PC1 received the mail. R2 says, okay, it's coming from network 3. It needs to go to network 4, but before, it didn't know where to send unknown packets. Well, this time it does, so it just sends it off. R1 says, oh yeah, network 4, we need to translate that back to a network 1. And then he gets it. He's happy as can be. Well, that is the video. Thank you again for watching. If you have any questions, further questions about NAT and how it works, we can make it a lot more complicated, but I tried to just simplify it this time. So if you have any questions or comments, or if I didn't explain something fully, please let me know and I will do my best to clarify. Please subscribe. We're coming out with cool videos like this for you guys so you can understand networking responsibilities and concepts a little bit better. I would love it if you guys would send me more questions with more requests for videos or things that you would like to learn more about. Talk to you guys later. Peace.